Imagine you had a superpower. What if you could see a hidden world that exists all around us, just beyond what our eyes are capable of seeing? Well, today, we're going to dive into the technology that actually makes that possible.
So let's start with that one big question. What if you could really, truly see the invisible forces and energies that are shaping our world every single day? You know, it sounds like something straight out of science fiction, but it's very, very real.
Okay, take a look at this. It might look like some kind of alien landscape, but this is a real forest, right here on planet Earth. And those wild, vibrant colors, they're not just for show. They are pure data, telling us a story about the health of this forest in a language our eyes just can't speak. But here's the cool part. By the end of this, you'll know exactly how to read it. So, how do we crack this code? How do we solve this mystery? Well, it all comes down to the science of seeing the world from a distance without ever actually having to leave home.
All right, let's get into it. First, we need to nail down the core idea that makes this whole thing possible.
The name for this superpower is remote sensing. At its heart, it's the science of gathering information from a distance. You can think of it like being a planetary detective, where all the clues are just hidden patterns of energy.
And what's really wild is that you're using a form of remote sensing right now. Your eyesight, that's remote sensing. You're collecting info about the world without touching it. Touch, on the other hand, is what scientists call in situ. It's a fancy term for being on site. Remote sensing just takes that basic idea of seeing and dials it up to a global scale.
So how do we actually do it? How do we manage to see things from hundreds of miles away, up in space?
Well, it really boils down to two main ways. First, you have passive sensors. These are a lot like our eyes. They just collect energy that's already out there, like sunlight bouncing off the Earth. But then you've got active sensors, which are more like a bat using sonar. They actually send out their own pulse of energy, think radar, and then they measure what bounces back. And that means they can see day or night, through clouds, rain or shine.
Now, this idea of getting a bigger perspective, a bird's eye view, it's definitely not new. In fact, we humans have been trying to map our world from a distance for centuries.
For most of history, if you wanted to build a map, you had to walk, or sail, and draw every little bit, piece by painful piece. Now, maps like these were absolutely incredible achievements, but they were always limited by what you could see from the ground. You could only map where you could go.
But then, our view started to change. It began with cameras on hot air balloons back in the 1860s. Then, the space race kicked things into high gear. 1957, Sputnik gives us our first real eye in the sky. But the real game changer was 1972, with the start of the Landsat program. That began a continuous, unbroken record of our planet that's still going strong today.
Okay, so we've got these incredible eyes in the sky, but how in the world do we decode what they're actually seeing? It's time to finally solve the mystery of that crazy red forest.
Right, so how do we get from just a raw stream of data beamed down from a satellite to an image that tells us something really important, like whether a forest is healthy or not?
The key is this right here. This is our secret decoder ring. It's called a spectral signature. And just like your fingerprint is unique to you, every single material on Earth, water, rock, a single leaf, it reflects and absorbs light in its own unique way. This graph is the light fingerprint for a plant, and it's how we see the invisible.
So, let's break it down. For photosynthesis, to make food, plants soak up a ton of red and blue light. They don't really need much green light, so they reflect it away, and that's why they look green to us. But here's the secret sauce. Healthy, happy plants reflect a massive amount of something called near-infrared light, or NIR. It's a part of the light spectrum that's totally invisible to our eyes, but to a satellite sensor, it's like a giant flashing beacon.
So, of course, scientists came up with a tool to measure this exact thing. It's called NDVI, which stands for Normalized Difference Vegetation Index. I know, it's a mouthful, but it's really just a super clever way to check how green and healthy an area is, all by looking at that invisible NIR light.
Now, the formula might look a little technical, but trust me, the logic is really simple. It's just a ratio. It compares the red light the plant is absorbing for energy against the near-infrared light it's reflecting when it's healthy. The bigger the difference between those two, the healthier the plant. That's it.
So what do the final numbers tell us? Well, think of it like this. If you get a high positive value, boom, that means you're looking at dense, healthy plants that are reflecting a ton of NIR. A lower value could mean the plants are stressed out, or maybe it's just bare soil. And if you see a negative value, that's almost always water, snow, or clouds.
So, let's go back to our mystery. That forest that looked like it was on fire? It's the complete opposite. What we're actually seeing is a special kind of image called a false color composite. Scientists took that invisible near-infrared data and just assigned it the color red so we could see it. So that intense red, that's a sign of a super healthy, thriving forest, literally glowing with an energy we could never see on our own.
So this is all really cool science, but why does it matter? Well, this ability to see the invisible isn't just a neat trick. It's become one of the most powerful tools we have for understanding our home planet.
With this superpower, we can track deforestation as it's happening, not years later. We can measure exactly how fast glaciers are melting. We can even check the health of our oceans by seeing tiny phytoplankton blooms from space. For the first time ever, we can truly see the big picture of how we interact with the Earth.
What it all boils down to is this. We've basically developed a way to give planet Earth a regular checkup. We can diagnose the health of the entire system, from the deepest oceans to the highest clouds, all from space.
And that leaves us with a pretty profound thought. You see, for the first time in all of human history, we are no longer blind to the huge planet-wide changes happening all around us. We can see them, clearly.
So the question is no longer what is happening. We can see that now. The real question is, now that we have this power to see everything, what will we choose to change?